In this video, I will show you how to solve problems involving chords, secants, and tangents inside of a circle. For problem number 1, we're using the formula part times part is equal to part times part. Here's what I mean. If we look at one chord, the two parts are 14 and x. So that's the part times part I'm talking about. I'm going to get 14x right there. If you look at the other chord, that's the 12 and the 21. So 14 times x is going to equal 12 times 21. So let's see, 12 times 21 is 252. So I've got 14x is equal to 252. Of course, then we will divide both sides by 14, and that will get x by itself. So x is equal to 18. Looking at problem number 2. Again, we will do part times part is equal to part times part. So looking at this chord right here, the part times part will be 6x. Looking at this chord, the part times part will be 12 times 7. And I guess I'll go ahead and just write that down for a quick second. So we will have 6x is equal to 84. Then of course we will divide both sides by 6. And let's see, 84 divided by 6 is 14. So x is equal to 14. Problem number 3. Let's go ahead and look at this chord first. So that will be, we're going to have 3x times 6 is equal to, now let's look at this chord, and we're going to have 8 times 2x plus 1. So again, we're doing part times part is equal to part times part. This will give us 18x is equal to, and with a little distributive property, we will have 16x plus 8. Subtract 16x from both sides. That will leave you with 2x is equal to 8. And when you divide by 2, you get x is equal to 4. Looking at problem number 4, let's look at this chord right here. So that will be, when we do part times part, that's 2x times 5. And then let's look at this chord right here. Part times part will be 4 times 2x plus 2. So on the left side, we get 10x. And then on the right side, with a little distributive property, we get 8x plus 8. Subtracting 8x from both sides, we get 2x is equal to 8. And then if we divide both sides by 2, we get x is equal to 4. Okay, when the secant line is reaching outside of the circle like this, the formula changes a little bit. So the formula now will be like this. Outer times the whole is equal to outer times the whole. And that's what they're alluding to here. So here is one secant line. And notice it has two parts to it. This is the outer part, which is 7. Now the whole is going to be x plus 7. Now let's look at another secant line, which is this. The outer part is this 8, but then the whole thing is 6 plus 8, which is 14. So when we do the formula, outer times whole is equal to outer times whole. From the first secant line, the outer was 7 and the whole was x plus 7. From the second secant line, the outer was 8 and then the whole was 14. So a little distributive property, and we have 7x plus 49 is equal to, and then 8 times 14 is 112. Let's subtract 49 from both sides. Okay, so that gives us 7x is equal to 63. Finally, when we divide both sides by 7, we end up with x is equal to 9. All right, let's do the same thing for problem number 6. Remember, it's outer times whole is equal to outer times whole. And we will do one secant line at a time. So here is one secant line right here. The outer number is this 6. The whole thing is going to be x plus 6. You have to add these two together. So it's going to be 6 times x plus 6. Now for the other secant line right here, the outer number is the 7s outside the circle. And then the whole number is going to be the 7 plus the 5. So the whole is going to be 12. So distributive property here gives us 6x plus 36 is equal to 84. Let's subtract 36 from both sides. So we have 6x is equal to 48. And then finally, when we divide both sides by 6, we get x is equal to 8. So for problem number 7, this is another outside times whole is equal to outside times whole problem. Let's start with this secant line. The outer number is 9. Okay, so you know what? Yeah, I'm going to squeeze it in right here. So we're doing outer times whole is equal to outer times whole. So the outer number is 9. So this is a little bit tricky. The whole, I need to add the 9 and the 10x plus 1. If I were to do 10x plus 1 plus 9, well, you see I have these like terms right here. That would make 10x plus 10. So that's what I get when I add these two things together. So you don't need to show this extra step off to the side. Just do this part in your head. And understand that if you add 10x plus 1 plus 9, the 1 and the 9 will make 10. So you will end up with 10x plus 10. So that's that secant line. So how about the blue secant line? Remember, we are doing outer times whole. This is the outer number right here. The outer number is 10. The whole is going to be 8 plus 10, which is 18. Now, the distributive property. I will get 90x plus 90. 10 times 18 is 180. Subtract 90 from both sides. All right, that looks like 186. Subtracting 90 from both sides, we'll get 90x is equal to 90. And then if I divide both sides by 90, I'm going to get x is equal to 1. Very interesting. I'm just remembering that I was supposed to be filling in these blanks. So for the yellow secant, the outside number was 9, and the whole thing was 10x plus 10. For the blue secant, the outside part was 10, and the whole was 18. All right, same deal for problem number 8. Here is the first secant line. All right, once again, we are doing outer times whole is equal to outer times whole. So for the yellow secant line, the outer part is this 5. Now the whole is going to be x plus 6 plus 5. All right, you should be able to do this in your head, but just to give you a little boost, if I have x plus 6 and then plus 5, the 6 and the 5 are like terms. So that's going to give me x plus 11 for the whole. Now let's look at the blue secant line. Outer times whole. The outer part is the 7, and the whole is 15. 7 plus 8. Distributive property. This will be 5x plus 55 is equal to 105. Subtracting 55 from both sides, that will give me 5x is equal to 50. And then divide both sides by 5 to get x by itself. Skirt. And we get x equals 10. These last two problems involve a special case of the outer times whole equals outer times whole rule. And the thing that makes it special is this secant line right here. Instead of a secant line, we have what's called a tangent line. See how this blue line just barely touches the outside edge of the circle. It doesn't cut through the interior circle like the yellow secant line does. So the blue line really is not a secant line. it is a tangent line. And when that happens, we get something special when we look at the outer and the whole. Because this blue line here, this is the outer part. It's clearly outside the circle, but there is no inner part. So it is also the whole. So this 30 is both of these numbers. This 30 is the outer part, and it happens to be the whole thing because there is nothing else. So we can modify the formula a little bit. I just mentioned to you that this blue line is called the tangent line. So when you have a tangent line, the tangent line is the outer part, as I just mentioned, and it is also the whole. So instead of having outer times whole equals outer times whole, the formula becomes outer times whole equals tangent times tangent. The reason why I'm taking the extra minute to write it that way is because we can now simplify it even more. Because tangent times tangent is tangent squared. So when you have a tangent segment, then we have outer times whole is equal to tangent squared. It's really just a special case of outer times whole equals outer times whole, where the tangent is the outer and the whole. But as a shortcut, you can say outer times whole and then equals tangent squared. So for the secant, shown here in yellow, the outside part is the 18. And then the whole thing is going to be x plus 18. And then the length of the tangent, shown here in blue, is 30. So when we use this shortcut, outer times whole, that's going to be 18 times x plus 18 is equal to tangent squared. So that will equal 30 squared. A little distributive property here. I'm going to have 18x plus, I'm forgetting what 18 times 18 is. $324. So that's equal to 324. Now, 30 squared is 900. It's time to subtract 324 from both sides. All right, this word tangent is a little bit in my way. So now I'm going to have 18x is equal to $576. And last step is to divide both sides by 18. So we get x is equal to 32. All right, last one, guys. Again, we have this tangent segment here shown in blue. So we have the tangent segment. It only touches the circle on the outer edge. But then we have the secant segment that cuts through in the interior of the circle. So this will allow us to use our our brand new shortcut that goes outer times whole for the secant is equal to tangent squared for the tangent. So this 6 right here is the outer part for the secant. Now let's be very careful. For the whole, I need to add 6 and 2x plus 6. When I do 2x plus 6 plus 6, when I add these two together, the two 6's make 12. So I'm going to end up with 2x plus 12. Of course, the tangent length is 12, so I'm going to have 12 squared. Little distributive property gives us 12x plus 72. And then 12 squared is 144. So let's subtract 72 from both sides and see what we get. So we have 12x is equal to 72. And then if we divide both sides by 12, that's going to give us x is equal to 6. Hey, I was wrong. I thought the last problem was the last problem, but there are two more problems. Both of these are still involving the special case of outer times whole is equal to tangent squared, because we have a secant line where we will do outer times whole, and then we have a tangent segment where we will do tangent squared. So outer times whole, well, this is the outer right here, so the outer is 32. And then the whole is going to be 50. Okay, I'm just doing 32 plus 18, which is 50. Now, that should equal tangent squared. The tangent is x, so I'm just going to have x squared. Very interesting. Let's see what 32 times 50 is. 32 times 50 is 1,600. So I will have 1,600 is equal to x squared. So in order to get x by itself, we need to take the square root of both sides. So that should give us x is equal to 40. Because that is the square root of 1,600. All right, so this really is the last problem. Outer times whole, we are talking about the secant segment. The 27 is the outside part. So I'm going to have my 27 first. And then the whole thing is the 27 plus the 48. So if I take this 27 plus the 48, I'm getting 75. So I have 27 times 75 is equal to the tangent squared. Well, the tangent is just x. So that'll equal x squared. What is 27 times 75? Uh, 2025. So I have 2025 is equal to x squared. Again, to get x by itself, we need to take the square root of both sides. So what is the square root of 2025? 45. And that really is the end.